If you are an ambitious, self-taught engineer, the kind of programmer who just devours every piece of internal research you can find, you have probably asked yourself this question.
I think we all have.
Why does software delivery feel so slow even when everyone on the team is, crushing it? They're working long hours, they're drowning in JRA tickets, and everyone is undeniably busy.
But the actual velocity of value delivered is just painful.
Exactly.
It's the invisible problem. So today we're here to sort of peel back the layers on what researchers call the dark matter of engineering productivity.
The dark matter.
Yeah, the systemic, the cultural, and the environmental friction that nobody measures, but that silently kills velocity and, frankly, drives burnout.
Now, a quick note before we jump in. This deep dive is AI generated. It's synthesized from rigorous human-curated research.
Right, we're talking about things like the Dora reports, Google's Project Aristotle findings, analyses on cognitive load, and the team topologies framework.
So we are really trying to cut through the generic AI slop to give you the specific, actionable insights that, staff engineers use to fix fundamentally broken systems.
And our mission here is to show you the paradigm shift that's needed. Because, you see, true productivity isn't about making engineers type faster or work longer hours.
It's not about activity.
It's not. It's about radically reducing the cognitive cost of every single action and maximizing collective flow, the velocity of decisions and value delivery through the entire system.
Because right now, the industry is just trapped in this measurement crisis. We're
Yeah.
trying to apply this legacy factory model, Taylorism, to manage knowledge work.
Precisely. Taylorism was about optimizing kinetic activity, how fast a worker could move a widget on an assembly line. When managers ask for output metrics today, they're falling back on that.
They're using industrial metrics that just inherently fail for knowledge workers.
They do. They measure activity, but they completely obscure the friction in the system.
Okay, let's unpack that friction because if you look at the history of software management, we've inherited some truly terrible metrics.
Oh, yeah. And they're still being weaponized in performance reviews today.
They are.
And the problem with bad metrics is that they create perverse incentives. The classic example is velocity points.
Right.
They were designed purely as an internal capacity planning tool for a team. But the moment managers use them as a performance metric for an individual,
You immediately get point inflation.
immediately, teams artificially bloat estimates. A task they know will take 3 days suddenly becomes 8 points just to look productive.
And it completely decouples the metric from any actual value being delivered.
It does. I've seen teams where the metrics look fantastic, but you look at the code and it's a total disaster.
Oh, what a pull request counts. You think you're encouraging throughput.
But you're actually just incentivizing fragmentation. It's the worst kind of vanity metric.
So an engineer breaks a feature into 20 tiny PRs or submits trivial changes just to hit a quota.
And that drives up so much noise in the review system, increasing the cognitive load on the reviewers, all without delivering any real consolidated value.
And then there's the one that should be ancient history. Lines of code, LOC.
It just rewards verbosity. It's terrible. Think about this scenario. A highly skilled senior engineer spends a day simplifying a complex microservice. They delete 500 lines of messy, confusing code.
By the metric, they've done negative work. They're penalized.
Exactly. At the same time, a junior who adds 1,000 lines of complicated bloat to achieve the same feature is rewarded. It's a measure that actively punishes clarity.
So it's focusing on the wrong vector entirely.
Completely. And to answer your initial question about why the system feels slow, we have to define this sluggishness. We call it productivity debt.
Okay, so technical debt is bad code. What exactly is productivity debt?
It's the accumulated friction in your processes, your culture, and your tooling. If technical debt is the interest you pay on bad design choices, then productivity debt is the cost of future action.
It's like trying to drive a car with the emergency brake on just a few clicks.
That's a perfect analogy. You're still moving, but the effort required to go 30 miles per hour is exponentially higher than it needs to be.
And if you leave that brake on forever, what's the psychological result on the team?
It leads to a state called learned helplessness. Your smartest, most ambitious engineers just stop trying to improve the system.
Because they lack the authority or the time or the tooling to fix the friction.
Right. They start to accept sluggishness, the
Yeah.
45-minute build, the bureaucracy as an immutable law of physics, and then they quit quietly.
That structural acceptance of slowness, it often starts not just with process, but with team organization, right? We need to shift focus from individual brilliance to how that brilliance is structured.
Absolutely. The single structural component that dictates speed is what we call the experience center of
The
gravity.
center of gravity.
Yeah. Most managers focus on the hero, the one brilliant engineer. But it's not the sheer presence of that hero that matters. It's the median relevant experience of the entire team. That median is the true predictor of autonomous decision speed.
But doesn't relying on a hero speed things up in the short term? I mean, they know all the answers. They're the fastest coder. Where does that break down?
It breaks down structurally into the hero-junior polarization anti-pattern. You end up with one staff architect supported by 5 or 6 junior engineers who haven't built up that pattern recognition yet.
And the hero saves the day, every day.
But in doing so, they become the permanent critical path. This creates the catastrophic review bottleneck.
Right, because the junior engineers who lack the context and the authority just sit idle in this waiting room. Every complex PR has to funnel through that one single overcapacity hero.
And this drops your bus factor to a critically low level, often just 1.
Define bus factor for us.
It's how many people need to get hit by a bus, so to speak, before the project stalls completely. With a hero, if they take a vacation or leave the company, the project becomes instantly unmaintainable. The knowledge was never distributed.
It was just rented from the hero's brain.
Exactly. So the hero, despite their high individual performance, becomes a structural liability. The research even calls them brilliant but toxic sometimes.
Because they destroy the long-term health of the team.
They do. They hoard knowledge, intentionally or not, and they mask the underlying inefficiency of the system. And they can create an intimidating environment where others are afraid to step up.
So how do we fix this center of gravity problem? How do we build resilience?
You need a T-shaped distribution. You need that strong middle class of experienced senior and mid-level engineers. In a balanced team, that middle layer has the collective muscle memory and the distributed authority.
A mid-level engineer should be able to approve most routine changes on their own.
They should be able to approve 80% of them without escalation.
And practically speaking, if you have a hero right now who's hoarding all that depth knowledge, how do you force that knowledge to be distributed?
A great tactic is to implement the rotation of Batman.
Batman.
It's the designated responder role for interruptions, on-call incidents. If you force the hero off that rotation for a fixed period, someone else must learn how to fix the system. It immediately starts raising your bus factor.
Let's shift gears to the silent killer of flow that every engineer faces, the cognitive tax.
Yeah, this comes from tooling inconsistency and the constant need to context switch. It starts with that phrase we all dread, "It works on my machine."
Which is not an individual failing.
No, it is a systemic failure of tooling parity.
Yeah.
When you have 2 developers on different operating systems or even different versions of the same local tool chain, the first step of debugging isn't problem analysis.
It's environmental forensics.
Exactly. You're trying to figure out if the bug is real or just an artifact of the local setup. I've seen this eat up 30% of a pairing session. It's pure waste.
And this ties directly into cognitive load theory,
It
right?
is. When you have to manually reconfigure your shell or juggle environment variables just to switch between microservices, that's extraneous load. It's mental effort imposed by the environment, and it consumes working memory that should be dedicated to solving the actual problem.
It's like having to run an entire operating system in your head just to write 3 lines of code.
That's it. So the goal has to be achieving zero cognitive overhead switching.
How do you do that?
You treat your development environment as an immutable product, using infrastructure as code. Technologies like dev containers allow you to define the entire toolchain in code.
So a new joiner's time to first commit goes from days of setup to minutes.
Minutes. You outsource the maintenance of your tools to the code itself, which frees up human working memory.
Okay, now let's talk about the biological reality of interruption. The context switching tax. We've all had those mornings where you try to start a complex task, but then a Slack ping, an impromptu meeting, and the whole morning is gone.
The neuroscience here is just unforgiving. The research points to the 23-minute rule.
23 minutes.
It takes approximately 23 minutes to get back to a state of deep focus after a significant interruption. And for complex engineering, that cost is even higher because your brain has to repopulate its RAM with the code's stack trace, that mental model you had built.
And this leads directly to what you call fragmentation fatigue. I've seen my calendar look 50% free, but if that time is shattered into these unusable 30-minute shards,
You rationally choose not to start a complex task.
Right. I default to shallow work email docs, and that 50% free time becomes 0% usable for deep work.
So you need structural protection for flow. This is the difference between the maker schedule and the manager schedule. The fix is non-negotiable maker blocks.
4-hour windows.
4-hour windows where synchronous communication is strictly forbidden. It's not a preference for introverts, it's a requirement for complex problem solving.
Okay, we defined productivity debt earlier as bad process. Let's look at two really tangible examples of where that friction costs us time in the deployment pipeline itself.
The classic bottleneck is the CI/CD pipeline. If your full test suite takes 45 minutes to run, the feedback loop is severed. The cognitive gap is just massive.
And developers respond to this rationally. They batch work, they write code for 4 hours, and then submit one massive 800-line pull request.
Which is statistically guaranteed to have more bugs and is way harder for the reviewer to parse. Another huge friction point is flaky tests.
Oh, this is a big one.
If tests fail randomly 5% of the time, what's the first thing everyone says?
Just rerun the build. We've all been on that team where the first line of defense is the coffee machine, then just restart the build.
Exactly. That's the normalization of deviance. The team learns to distrust the signal of the system, they waste time restarting builds, and then they ignore the moment when the build fails for a real reason.
And the psychological impact of all this friction, the lockdown proxy, the slow build server you can't fix, is that learned helplessness we mentioned.
Morale just plummets. Engineers stop trying to improve the environment. The fix is to shift to the DivX's product model.
You treat internal tooling like a product with its own product manager and budget.
And if the build time exceeds 10 minutes, it's a P0 incident. You signal to your engineers that their time is the most valuable asset you have.
And this brings us back to decision latency. Project delays are rarely slow typing. They are slow decisions.
The consensus trap is everywhere, and it's often born from good intentions. Organizations create the committee problem.
An architecture review board.
Yes. A technical decision that two experienced engineers could make in an hour is routed to a board that meets once a week. You've just inserted a guaranteed 5-day latency block into your workflow.
And that latency is devastating because while the team waits, they don't stop working. They pick up filler tasks, which increases work in progress, or WIP.
Which is where Little's Law comes in. The math proves that high WIP is mathematically guaranteed to increase your cycle time. More open tasks equals slower delivery. Period.
So the solution has to assign clear decision rights.
You need something like the DCI model driver, approver, contributor, informed, to assign a single approver. And crucially, high-velocity teams couple this with the 24-hour rule.
Which means?
If the designated approver doesn't explicitly object within 24 hours of a proposal, the decision is ratified by default. You shift the default state from waiting to acting.
We've spent a lot of time on technical and structural friction, but none of that matters if the cultural foundation is broken. This brings us to Google's Project Aristotle.
Right. Project Aristotle studied 180 of their internal teams to figure out what made the difference between high-performing and low-performing ones. The result was definitive. Psychological safety was the #1 predictor.
Not skill, not experience.
Not even who was on the team. It was how they interacted.
Can you define psychological safety for us in that context?
It's the shared belief that the team is safe for interpersonal risk-taking. It means you can ask a stupid question, admit a mistake, or challenge a senior leader's design without fear of humiliation or punishment.
And what's the cost of not having that safety? What does that fear tax look like?
It's rampant impression management. Engineers hide bugs, they cover up near misses, and they stay silent during planning even if they see a huge flaw because they fear ridicule.
And that effort spent managing your manager's impression of you consumes resources that should be used for problem solving.
Absolutely. And
Yeah.
it just tanks innovation because innovation requires failure. If failure is punished, people stop taking necessary risks.
The data actually shows that safe teams report more errors, right?
They do. Not because they make more mistakes, but because they're willing to expose them immediately. That radical transparency allows the system to be fixed. Unsafe teams hide the error until it becomes a catastrophic outage.
So the single most crucial practice we all must adopt is the blameless postmortem.
Yes, the entire focus has to shift from who broke the build to how did the system allow the build to be broken.
It frames the engineer not as the cause, but as the investigator.
Exactly. It turns every incident into a learning opportunity rather than a witch hunt, which is essential for building that trust.
Okay, finally, we have to talk about incentives, because as we've seen, Goodhart's law is real. When a measure becomes a target, it ceases to be a good measure.
And misaligned incentives will destroy all the gains you make in flow. If you reward individual performance, say based on closed tickets, you actively destroy collaboration.
The question becomes, why would I spend 4 hours helping a colleague debug their issue if that doesn't show up on my scorecard?
It directly incentivizes knowledge hoarding and siloing.
So we need to move teams away from operating as feature factories that focus purely on volume and toward focusing on value and impact.
The final alignment is using outcome metrics. Incentives have to be tied to business results. We stop asking, how many tickets did you close, and
Hmm.
start asking,
Did the latency improvements we shipped actually increase customer conversion?
or did this refactoring reduce churn? It forces engineering and product to align on the value of the work, not just the volume.
So if we synthesize everything we've covered today, the core message is pretty clear. To solve this productivity crisis, organizations have to stop trying to manage the individuals and start managing the system itself.
We need a system that flows with less friction.
Yeah.
You need to raise that median experience, move to T-shaped teams to decentralize authority. You have to implement dev containers or similar tooling to eliminate that cognitive tax.
You have to protect the maker's schedule with enforced maker blocks for deep work. You must treat your internal DevX as a product to fight back against that productivity debt and learned helplessness.
And foundationally, you have to embrace blameless postmortems and align all your incentives with outcome metrics instead of individual output.
Now, think about your own team right now. If productivity is fundamentally about reducing friction, what single point of invisible friction, that process, that slow tool, that weekly meeting, are you currently accepting as an immutable law of physics?
Because you now have the checklist and the language to challenge that friction and to start achieving true flow.